Hello everyone, welcome to Physics. In this video, we break down the single most important tool in physics, and that is differentiation. We won't start with formulas, we'll start with intuition. And let's start with a video. We have just seen a fast bowler deliver a ball, and the speed gun flashes 150 km per hour. But wait, what does that number really mean? Is that the ball's average speed? No, that's the speed at the exact instant it left the bowler's hand. But this creates a problem. An instant has zero time, that is delta t is equals to 0. In that instant, the ball travels 0 distance. So is the speed 0 by 0? How can we even talk about the speed at an instant? This exact problem confused the greatest scientists for centuries. The tool they invented to solve it is the first key in our physics toolkit. It's called differentiation. But we are not going to start with formulas. We'll show you what it is. Forget the name calculus. Think of it as a slow motion zoom lens. Imagine a graph of a car's journey. The line is curvy. It means the car is speeding up and slowing down. If you want the average speed between 2 points, say point A and point B, that's easy. You just draw a straight line between them and find its slope. That's total distance by total time, or delta y by delta x, as you would say in math. But that's the average. It doesn't tell you the speed at the exact moment you passed that speed camera at point A. This is where our slow motion zoom lens comes in. Let's zoom in on a tiny section of the curve right around the point A. As we keep zooming in, what happens? That little piece of the curve, it starts to look straight. And what's the slope of a straight line? It's constant. That slope, the slope of that infinitely zoomed in piece of the curve, is your instantaneous speed at point A. That's all differentiation is. It's a mathematical tool that does this infinite zoom in for us. It finds the slope of the tangent at any point on a curve. It turns a complex, curvy problem like changing velocity into simple, straight line problem like velocity at an instant. So how does the math tell this exact same story? As explained in books like H.C. Verma, we have our 2 points A and B. The slope of the line connecting them is delta y by delta x. This is our average rate of change. Now we do our zoom in trick. We make point B get closer and closer and closer to point A. This means we are making the change in x, which is delta x, smaller and smaller. We are making it approach 0. As delta x approaches 0, that connecting line AB becomes a tangent at point A. This zoom in process is what mathematicians call a limit. We write it like this. And that's it. dy by dx is just the name for the slope of the tangent at that single point. It is the instantaneous rate of change. So what does this tool do for us in physics? If we have a graph of position x versus time t, then dx by dt is the instantaneous velocity v. If we have a graph of velocity v versus time t, then dv by dt is the instantaneous acceleration a. So here is the trap that stumps 90% of students in JEE and NEET. They'll ask, a ball is thrown up. What is its acceleration at the highest point? Most students think, at the highest point, the ball stops for an instant, so its velocity v is 0. If v is 0, acceleration a must also be 0. That's completely wrong. Think with your new calculus toolkit. Acceleration isn't v, acceleration is a is equals to dv by dt. It's the rate of change of velocity. So the real question is the velocity changing at that highest point? Yes, it's changing from positive going up to negative going down. The rate of change is not zero, since velocity is a vector, and we will discuss vectors in coming videos. Here is the architect's insight. A quantity is at a maximum or a minimum when its rate of change is zero. At the highest point, the height h is at a maximum. This means the rate of change of height dh by dt must be zero. And what is dh by dt? It's the velocity. So v is equals to 0 at the top because h is maximum. But the acceleration a is equals to dv by dt is the rate of change of velocity, which is not 0, it's minus g. That's the difference. Differentiation gives us a precise language for how things change. In the next part of our toolkit, we'll learn how to do the reverse, how to find the total from all the tiny changes. That's called integration. And we'll look at it in the next video. Thank you.